what can you multiply by that doesn't change anything? 1, okay? And the inverse in multiplication is its reciprocal. Like if I had 2, 2 times 1/2 gives me 1. So I just want you to understand what an identity is. An identity matrix is a matrix that if I multiplied it, it would not change the value of the original matrix, okay? For square matrices only, that's really what we're going to deal with. The identity matrix looks like this. So what do you notice about it? A lot of what? Zeros. And we see ones, but where are the ones located? On that diagonal line. Okay? So just for example, let's start with a 2 by 2. The identity of a 2 by 2 would be 1, 0, 0, 1. In other words, if I was multiplying by a 2 by 2 matrix and I multiplied it by 1, 0, 0, 1, it wouldn't change the matrix at all. That's what that means. Let's do a 3 by 3, just so you get an idea. 1, 0, 0, 0, 1, 0, 0, 0, 1 is the identity in a 3 by 3 matrix, because when I multiply it, it doesn't change the value of the matrix. I hope you see why. If I have a 1 here and then I had a column over here, do you see how it would keep that first one, but then you're multiplying the other 2 by 0, so it would cancel them out, and then it continues to do that on each row. Okay, what would a 4 by 4 be? Give me the 4 by 4. Okay, so you get the idea there. So, and if you don't believe me, I'm gonna show you something here. I'm gonna go into matrix A. I'm gonna edit. All right, do you guys see this matrix that I have in here? Can you see it? All right, can you see it now? Okay. I stored that in matrix A. What I'm going to do is I'm going to put the 3 by 3 identity in matrix B and show you by using matrix on your calculator, even though we could do it by hand, that I'm going to get, it's not going to change it. Okay, so I'm going to get out of here. I'm going to go matrix again. I'm going to edit another matrix. That's what I want. And I'm going to put 1, delete 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, now notice I put the identity in matrix B. Okay. Do you remember what matrix A was again? Should we look? Actually, I'm going to just do this. If you say names and you go like this and you hit enter and you do that, it will put it up for you. So that's what matrix A is. Okay, now I'm going to do matrix A times matrix B. What? Did it change? No. Okay, and you guys could, that was a quick way of doing it, but you could do, you showed me yesterday, you know how to do the row by column. You would get the same thing if you multiplied them up. Okay, so that's what an identity is. How do I get an identity? How would I take a matrix? Because remember how we said that every operation has an identity and an inverse. Identity in addition is 0. To get its inverse, you take the negative. Multiplication, the identity is 1. To get it, you multiply the number by its reciprocal. So if this follows, we should be able to figure out the inverse of a square matrix then. Here's what I'm going to tell you. To do anything beyond a 2 by 2 requires a ton of time. Some years I'll have students find just a portion of a 3 by 3, but anything beyond a 2 by 2 is beyond the scope of what we're going to do in class. You can use your calculator for the inverse of anything beyond a 2 by 2. Here's the formula for finding the inverse of a square matrix, and you don't have to memorize it, you just have to know how it works. Okay, so To find the inverse of a square matrix, first of all, look at that notation, little -1. We've seen that before. Realize that doesn't mean 1 divided by, it means inverse. What we do is if I had a matrix A, B, C, D, and I wanted to find its inverse, the first thing is we take 1 divided by some number, AD minus BC. What does that mean? That means A times D, you figure out what it is, minus B times C, and you put it on the outside. And then you're going to multiply by a new matrix that's kind of made up of this matrix. What do you notice about it? How does it change from here to here? Give me one way. B and C are the same spot, but they're just negative. And what do you notice? Do you see how A and D are just switched around? Okay. Again, you don't have to memorize it, but that's where that new matrix comes from. Don't forget this. This right here, did I write it down anywhere? This right here is called the determinant of a matrix. Okay. So, I'm going to show you how it works then. So, I made a real basic matrix, A, 1, 3, 2, 5. I want to find A inverse. So what I first do is I'm going to find, I'm going to do 1 over, and I'm going to do A times D minus B times C. So A times D is 1 times 5 minus B times C is 3 times 2. I'll figure out what all that is in a second. It's a really small number in this case. I'm then going to take that fraction, I'm going to multiply by, I'm going to flip the A and D around, so I'm going to put the 5 here and the 1 here. And then I'm going to make B and C opposites, so -3 and -2. How are we doing so far? Okay. All right, what is 5 minus 6? So this is 1 divided by -1, which is just -1, right? Times 5, -3, -2, 1. This gives me the matrix -5, +3, +2, -1. This is the inverse matrix. Okay. Did I go too fast? I'll wait a second. Now, let me show you what I did. If I multiply the original matrix by its inverse, what should the result be? No. If I take the original matrix and I multiply by its inverse, nope. It should, no. What's the identity of a square matrix? Okay, let's go backwards. Think back to addition. If the number 2, what's the inverse of 2 in addition? -2. What's 2 plus -2? The identity. The identity. Okay? In multiplication, let's take 2. What's the inverse in multiplication? And I do 2 times 1/2 and I get 1, which is the identity. So it should still work with matrices. If I take a matrix times its inverse, I should get the identity. And what's the identity of a 2 by 2 matrix? 1, 0, 0, 1. So if you are asked to confirm if 2 things are inverses, you are going to want to multiply them together and see if we get the identity. So if we did that correctly, it should work. Now, just because I want to practice my matrix multiplication by hand, I am going to do this. A times A inverse. We're going to all do this together. We're practicing. Let's take our original matrix, which was 1, 3, 2, 5, and we're going to multiply it by what we found as the inverse. -5, 3, to negative 1. All right, are you ready? Row by column. And now, I know that this is kind of like, I always tell you to show your work, but we're doing this fast right now. I'm going to have you do it in our heads. Are we ready? What's 1 times negative 5? Negative 5 plus 6. What's negative 5 plus 6?
1.
I'm good so far. Now I'm going to do row 1 times column 2. What's 1 times 3? And then what's 3 times negative 1? Negative 3. And what's 3 plus negative 3? 0. Doing good. Now let's do row 2. 2, 5 times negative 5, 2. What's 2 times negative 5? Negative 10 plus 10 is 0. And row 2 times column 2 gives me 6 minus 5, which is 1. Yay! I did it. Bam. Okay, so today, if you're asked to confirm if I give you 2 matrices already, don't do the work to find the inverse, just multiply them together. And you may use your calculator to multiply them together and see if you get the identity. Does that make sense?
Yep.
Determinant for a square matrix. Oh, here, some years I did this. Oh my gosh, it's so fun. It's so much fun.
No,
Yes, it is.
I don't believe it.
What you have to do is you take, to find the determinant of any square matrix, you take this like row and, oh, it's fun, but it takes about 10 minutes to do a 3 by 3, just to find the determinant of it. Remember how I said it's beyond the scope of our course? We're not doing it this year, okay? What you're going to use, though, is the determinant button on your calculator if I ask you to do anything beyond a 2 by 2, because for a 2 by 2, the determinant is just that, so not a lot of work required, right? Hey, by the way, what would happen if the determinant was 0? What would happen here if the determinant was 0? I'd have 1 divided by 0. Can we divide by 0? No. Okay, so there are some inverses that do not exist, and the reason an inverse would not exist is if the determinant were 0. That's the only time an inverse does not exist. Okay, so that's really why you find the determinant, to determine if an inverse has, or a matrix has an inverse or not. Okay, why is it all blurry? What did I want to show you? Oh, here's what we're going to do. Okay, last thing. I don't know if this works or not. Okay. So let's say I had matrix A. Notice this is a 3 by 3, right? What was the largest we're going to find the inverse of again? Nope. Go back. What did we find the inverse of? The largest I'm going to ever ask you is a 2 by 2. So what if this shows up on your homework? So number 1, what if I ask you to find the determinant of A? And what if I ask you to find A inverse? Okay, well then what you're going to do is you're going to use your calculator, and I'm going to show you that piece right now. Okay? Are we ready?
Yes.
All right, so first turn it on. Clear out your screen. Well, I'm going really slow. Okay. Now we're going to do second x negative 1, because that's where the matrix key is. Okay. You should see that. Now, you might not have 3 by 3 already on here, so I'm going to show you how to do that. What you're going to do is you're going to arrow over to the edit menu. And then you're going to select enter. And if yours is not a 3 by 3, you may adjust that now. Once you adjust that, you're going to take your matrix and you're going to put it in here. I made this up, so I don't know if this one has an inverse or not, but we'll be able to tell pretty quickly. Let me know when you're ready to go. Well, I don't know, Paul.
Let's do it.
Then I'm going to have somebody be like, oh, wait, you went too fast. Are you with me? Can I go? Okay. To do anything with the inverses, you got to get into your main screen, so you're going to have to quit. To quit, you type second mode, and then you get to a blank screen like this. Okay, so we have to start there. First of all, inverse. To do the inverse, we are just going to use the inverse button, which the inverse button is right here. But we're going to type the matrix in first. So we're going to go second matrix again, so second it. But you're not going to go over to the edit. You're going to just use the names. You're going to select number 1 by just hitting the enter, and then it should pop up on your screen. And then you're going to use the inverse button, and you're going to hit enter, and you should get a new matrix. Good, it worked. And do you see you can't see the whole thing?
Yes,
Oh, crap, you got to scroll. So if I wanted a inverse then, are we all good? We could transfer that to our paper. Okay, cool. Did you guys get the same thing I got? To find the determinant of any matrix, let's go to the matrix menu again. And remember how I said there's whole courses dedicated to this? Okay, there's all sorts of things we can do, but the very first thing under math is determinant. If you're asked to find the determinant of a matrix, you're going to just do determinant and plop your matrix in there. So the determinant of that matrix was negative 15. Okay. All right, that's it. So, we have some questions in your book today. So anything that I ask you to do today can be done on your calculator, but you just need to show me what you typed in your calculator. I will tell you there are some that you can't do with your calculator because they have A's and B's. So you have to do it by hand. Well, you have to know where the multiplication is. This is on page 531. So, those of you who are taking the end step tomorrow, this is the exact same thing I will do tomorrow in class. Except they won't have as much fun as we did.